Alright guys, so today I'm going to be talking to you about two main topics. One of them is prime factorization, and that's what I have here. Before we talk about prime factorization, we need to first talk about what it means when we say prime. So we're talking about specifically prime numbers. So what a prime number is it's going to be any number where the only two things that can go into it is one in itself. So for example, a prime number that all of us know is 3. 3 can only have 3 or itself go into it. 2 is a prime number. So some of the basic ones are going to be 2, 3, 5, 7, 9, 11, and so forth. Okay, so any number, and these are just a few examples, that only one in itself can go into. So if we look at 20 and we want to get the prime factorization of 20, we basically want to break it down into all of its prime factors. Okay, so what we're going to do is something that is called a factor tree. So when you look at your number, you want to first figure out a prime number that you know can go into it. So for example, if we look at 20, we know for a fact that 2 can go into 20, okay? So what I'm going to do is I'm going to break this up into 2 and 20 divided by 2 is 10. So I can break this up into 2 and 10 because 2 times 10 is 20. 2 is a prime number, so we're done with that. 10 is not, so we need to keep going. We can keep breaking this down, okay? So again, you're going to look at 10 and you want to find a prime number that you know goes into 10. Well, 2 goes into 10 as well. So I'm going to break 10 up into 2 and 5 because 2 times 5 is 10. Well, both of these are prime numbers, so we are done. The way you would then write this out is the prime factorization of 20 would be 2 times 2 times 5. That is the prime factorization of 20. Okay. You can also do prime factorization with variables. So for example, if we look over here, if we have 12x squared, we can get the prime factorization of 12x squared by breaking down both 12 and that x squared. So I'm going to start first with 12, and I'm going to get the factor tree of 12. Okay, so I know for sure that 2 can go into 12. Breaks down to 2 and 6 because 12 divided by 2 is 6. So 2 is prime. I'm going to go ahead and circle it. 6 is not done yet because 2 can also go into 6 as well. So you can break that down into 2 and 3. So we've got 2 and 3. 3 is prime, so we have the prime factorization of 12, which is 2 times 2 times 3. Now we need to look at x squared. When you're doing the prime factorization of variables, you just want to break it down to its letter. So for example, the prime factorization of x squared would break down to x and x. So it'd be x times x. So 2 times 2 times 3 times x would be the prime factorization of 12x squared. Okay, let's do one more just to make sure we really have it down. So I'm going to look here where we have 24x squared y to the third. So we're going to take this 24 and we're going to break that down, and then we want to break down the x squared and the y to the third as well. So if we take 24 specifically, 2 can go into 24, and it goes into 24 12 times. So 2 divided by 24 is 12. And ironically, we're now back to the number that we just did the prime factorization of, so you can go back and look at that, but we'll go through it again. 12 can break up into 2 and 6, so we've got 2 there, and 6 can break up to 2 and 3. So the prime factorization of just 24 is 2 times 2 times 2 times 3. And then we also have an x squared, which just breaks up into x and x. And then y to the third can take a y out of that, And then you got y squared, and then that breaks up into y and y. So it's just y times y times y. So we've got 2 times 2 times 2 times 3 times x times x times y times y times y. There would be our prime factorization of 24x squared y to the third. Notice all these worked out to where 2 goes into each of them every time. That's not always going to be the case. You might also have situations where your prime factorization is, 3, 3, and 5, or 5, 7, and 9, whatever it might be. These just happen to have a lot of 2's in them, so don't always automatically assume 2 is going to be the first prime number that can go into whatever number you're trying to find a prime factorization of, okay? Sometimes you'll get something where 3 is the first number that will go into it. Okay, so that's prime factorization. The next thing I want to talk about is something called GCF. So, bring this over here. GCF is also known as the greatest common factor, okay? And when you're finding the GCF of specific numbers or terms, you are trying to find the biggest number that can go into both of them, hence the greatest common factor. So for example, if we look at 20 and 35 and we want to find the greatest common factor, the biggest factor that can go into both of these is 5. So your greatest common factor here would be 5. Does that make sense? Because 20 divided by 5 is 4, 35 divided by 5 is 7. So your greatest common factor here is 5. So anytime you're given two numbers, you're just trying to break it down to where you can find the biggest number that goes into both of them. If we're looking over here, when you have variables, so let's say we're trying to find the GCF of 10, x to the 10th, y to the 7th, and then x to the 3rd, y to the 11th, you always want to pick the smallest exponent, okay? So for example, you want to look at each separate term, so the x's and then the y's. So we've got x to the 10th and x to the 3rd. Well, the biggest number that can go into both of those is x to the 3rd, okay? Because you can have 3 x's here and you definitely have 3 x's here. So you've got x to the 3rd, and then if you're looking at y to the 7th and y to the 11th, again, you want to get the biggest number that can go into it, which in this situation is 7. So you've got y to the 7th and y to the 11th. Well, you can have 7 y's here, and you definitely have 7 y's here, so it's going to be y to the 7th. So basically, when you're finding the GCF with variables, you always want to pick the smaller exponent, because that one is going to be the one that can go into all of them. You can't do like x to the 10th, because x to the 10th is not going to go into x to the 3rd, because you only have 3 x's. So that's kind of how you want to deal with something like that. Okay. You also can factor using GCF. All right. And this whole unit is about factoring. And basically, when you factor, you are trying to break down whatever polynomial you have into its simplest form. Okay, so the first thing you look for when you're factoring, and we'll do a lot of factoring throughout this unit, but the first thing you look for is a GCF. So for example, if we're looking at this 4x plus 20, and you want to factor this using the greatest common factor, you need to find the biggest term that can go into both of these numbers, the 4 and the 20. Well, in this situation, it's 4, because you can take this and divide by 4 and that divided by 4. So basically, you want to take both of these and divide them by the greatest common factor, which is 4 in this situation. So I'm going to divide both of these by 4. And you want to bring that 4 out. So you're going to write that 4 to the side. And then when you divide both of those by 4, you want to write down what you get in parentheses. So 4x divided by 4 is just a 1x. And then 20 divided by 4 is 5. So when you factor using GCF 4x plus 20, you end up with 4 times x plus 5. It's kind of like undoing the distributive property. So you can always check to make sure you did it correctly by saying, okay, if I distribute this 4, would I get 4x plus 20? Well, 4 times x is 4x, 4 times 5 is 20. Yes. So you know you made it down to factoring by GCF. Does that make sense? Now, let's say you notice that 2 goes into both of these. So you first take 2 out of both, and then you get a 2x plus 10. Well, when you get 2x plus 10, you're still not factored all the way down. So then you would notice that you could take a 2 out again. So let's say that happens. So let me show you what would happen in that situation. So I'm going to go to the back and show you that. So let's say we have this, once again, this 4x plus 20, okay? And maybe you don't notice right away that 4 can go into both of those. That's fine, but you notice 2 can go into both of those. So you take this and you divide it by 2, because you know 2 can go into both. Okay, so we're going to divide both these by 2. So I'm going to write my 2 out, and then in parentheses, you now have a 2x plus 10. You should then notice, okay, this 2x plus 10 is not done, because 2 can go into 2 and 10. So you would do the process again. So you would take this, and you would divide both of these terms by 2, and you need to pull that 2 out in front again. When you do that, you're multiplying. So you've got the 2 you already had, the new 2, and then now you have x plus 5. Well, 2 times 2 is 4, so you still end up with your same answer as 4 times x plus 5. Okay, you always want to break it down as far as you can. So if you can't see that 4 goes into those right away, that's okay. You can keep breaking it down till you get to this final step by taking by taking out the GCF. So let's go back to these other examples just to see a few more. So here we got a negative 30x squared plus 9x. So maybe right away, the first thing you should notice here, hopefully, is that 3 can go into both of these. So it's definitely true, but you also need to pay attention to the variables here. We have an x squared and an x. The smaller exponent here is this x to the first, right? This is like having an x to a first. So you can have an x that goes into both of these and a 3. So you want to divide both terms by 3x. I'm going to circle that 3x. Okay, so you want to pull the 3x out. When you take a negative 30x squared divided by 3x, you get a negative 10x. And then a 9x divided by 3x is just plus 3. And that would be your answer, because you cannot break that down any further. Okay. So let's do another one. Let's say, okay, so let's look at this one right here, this 6x squared minus 36x plus 42. So some of you right now might be able to tell, okay, 6 can go into all these numbers. But I'm going to say for our sake that the only thing you noticed right away was that 2 can go into these. So you can see the process to break it all the way down if you can't see right away that 6 goes into every single term. So I'm going to start by pulling a 2 out, because I know 2 can go into every single one of these terms. So when I divide this 6 by 2, I get 3x squared. Here, negative 36 divided by 2 becomes an 18, negative 18x. And then 42 divided by 2 becomes a 21, a positive 21. Okay, so now when you get down to this point, you have a 3x squared minus 18x plus 21. Notice we can't do anything with the x's because there's no x in this last term. Because there isn't an x with the 21, you cannot take that as part of the GCF. Okay, it would not work here. So what I want to do at this point is keep breaking down though, because now I have a 3 and negative 18 and a 21. And the greatest common factor of those 3 numbers is 3. So I can divide all of these by 3. Okay, so now I want to take a 3 out. So I've got 2 times 3 now. And left inside my parentheses is an x squared. This is a negative 6x, and this is a plus 7. You want to take the 2 times 3, which is 6. X squared minus 6x plus 7. And there is my final answer. So again, you might be able to see right away that x can go into, that 6 can go into all those terms. If so, awesome. You can go straight to this part. But some people can't see that, so I kind of wanted to show you the step by step on how you could break that down. All right, so I want to do one more example with you guys, and then you have a homework assignment for you to do. It is due tomorrow. It's what you'll turn in tomorrow as your attendance grade. Okay, it's going to be a homework, and it will be counted as a homework grade. It's very similar to what we did in this video. So if we look at this last example now, we've got 44x squared y to the third plus 22xy squared plus 33xy. So what you want to do is you want to kind of break this up into the three different parts. So we've got the numbers, right? You've got your coefficients, you've got your x's, and then you have your y's. Okay, and you want to find specifically the GCF of each of those different parts. So if we start by just looking at the coefficients, all three of these coefficients have one specific number that can go into them, and that's 11. Okay, so I'm going to go ahead and write that underneath all of these because I know 11 can go into each of these numbers. And then I'm going to look at the x's. So I've got x squared, I've got x, and I've got x. Okay, I know that x can go into every single one of these. Not x squared though, because x squared can't go into the x's, so it's just x. And then I have y to the third, y squared, and y. And in this situation, y can go into all three of those. So basically this 11xy right here that I'm dividing all these out by, that's my GCF. Okay, so I'm going to write that out. So I've got 11xy, and now in my parentheses I want to divide each of these by 11xy. So first we got 44 divided by 11, that's 4. X squared divided by x, that's x. Y to the third divided by y is y squared. Now we got the next term. 22 divided by 11 is 2. X divided by x is just 1, so that's gone. And then y squared divided by y is a y. And then we have 33xy. 33 divided by 11 is a 3. And then x over x becomes 1. Y over y becomes 1 as well. So this right here is our final answer. All right, awesome. So that is prime factorization and GCF. Okay, this is the start of our factoring unit. This is kind of the basics to get us started. You definitely have to know and understand GCF before we can move on and keep going. So make sure you do the homework for specifically this section. I'm going to go on for a Canvas chat live at 11:30 today to get any specific questions you might have because this is the first new step in this chapter. So at 11:30, if you want to come on and ask any questions on any of these examples or anything on your homework, I will see you then. All right, bye.